thank you for joining us today for today's Tech in 20 demonstration of Aruba EdgeConnect. Aruba EdgeConnect unifies SD-WAN, routing, firewall, segmentation, WAN optimization, and application visibility and control in a single centrally managed platform, forming the foundation for secure access services architecture. Today's demonstration will be given by Eric O'Brien, Principal Mobility Architect, and Pratik Baraj, Network Architect at Vandis. We are recording today's demonstration, so a quick reminder to mute your phone or computer microphone to eliminate any background noise. Feel free to submit your questions in the chat window, and we will address them at the end of the session. I'd like to provide a quick introduction for those of you who are new to Vandis. Vandis provides managed services and IT solutions to optimize the security and performance of network infrastructures, both on-premise and in the cloud. We design IT solutions to meet each organization's unique needs and goals. For over 38 years, from mid-market to enterprise clients, Vandis has delivered comprehensive strategies for secure IT infrastructures. And now I would like to turn it over to Eric and Pratik to begin the demonstration.
Thank you, Joanne. As my name is Eric O'Brien, I'm the Principal Mobility Architect over here at Vandis, and I'm joined by my colleague, Pratik, who will be sitting here assisting me with this slide deck as well as going through the demos. The goal here is to give you an overview on what Aruba EdgeConnect is, what it gets to here and offer for you, and then demonstrate some of the abilities that it has for it to be able to fail over and the seamless failover it has within the actual orchestrator itself. So for those who don't know, Aruba EdgeConnect is an Aruba product, was acquired from a company named Silver Peak. A little background on Aruba, for those who are not familiar, they're a leader of the Magic Quadrant for both wired and wireless for quite some time now. Definitely a leader in the WAN edge of the infrastructure, and you can see the numerous different awards. And the solution itself was acquired by Aruba from Silver Peak in 2020, which is now rebranded as the Aruba EdgeConnect. Aruba and HP have been in partnership and working closely for over 15 years. We are one of their top level partners in the Northeast and have one of the largest certified Aruba engineering teams that are out there. I can proudly say that a number of my members of my team do hold these certifications and hold them proudly. And additionally, we do sit on the advisory council, which is a feat in itself within Aruba partnership. So the reason why you're all here is why Aruba EdgeConnect. The Aruba EdgeConnect allows you to see here and deploy the SD-WAN within your environment as a separate appliance, and it's pretty much a self-driving cloud-first WAN experience. It sits here and brings all of your SD-WAN, your routing, your firewall, and segmentation, and WAN optimization, as well as the application visibility into a centralized platform, which is your Orchestrator. It's the foundation of your SASE architecture. The end users experience a consistent application performance over broadband connections, real-time monitoring, adaptation, and automated response, and the highest performance availability, whether the application resides in the data center or the cloud. We'll be showing this in a few different slides. Don't worry, we're not going to inundate you with that. It's not the purpose of being here. We kind of want to get through the nitty-gritty of these slides and then move on. A couple of the key features we'll be touching on: zero-touch provisioning. A lot of people sit here and push that right here. The Aruba EdgeConnect, it is readily available to easily deploy these appliances, either be on the cloud or on-prem, physical or virtual, and get them up and running with zero to no time, and have templates you can sit here and push, so you can get everything up and running in next to no time and in a very automated fashion. You see here and you have your dynamic path control to ensure that you have your traffic going over the most reliable link, let it be an MPLS connection, a broadband connection, or even LTE. You also see here and have your WAN hardening, so you can see here and have this directly facing the internet and make sure you're securing your internet and your ISP and your environment behind there properly. You also have your path conditioning, a little bit of a differentiator here, just in case the packets are out of order or you're being dropped on a regular residential broadband, because who knows what kind of a ISP is available. So it sits here, can make that public internet more of a private line-like feel, just to make sure that you don't miss these packets, they're not out of order, and everything continues business as usual. And lastly, the cloud intelligence. They have application definitions for more than 10,000 SaaS applications, 300 million web domains. These keep automating, updating. And then also when you're sitting here building out your business intent overlays to see your defined applications, you could do this on a custom basis as well in the event that you need to do that for custom ports and applications. A lot of homegrown applications still do exist these days, but so you can see here and handle them as in here. So important terminology to see here and dive into is the orchestrator. That's where everything actually happens. That's a single pane of glass that we're going to be using during this slideshow. The zero-touch provisioning, which I alluded to earlier, to see here and assist with rolling out devices with little to no interaction, have templates being pushed. The overlay, the actual having or molding the traffic to ensure that you have the reliability there and identifying it. The underlay being your ISP. Your business intent overlay, which is the actual definition of what traffic falls where and how it should be handled. Your subnet sharing, which is preparatory to this solution. Think of BGP without having to do route maps, essentially. So you know where to share what subnets for routing purposes and where everything should go. And lastly, the boost. The boost is to see here the ability to speed up some of that traffic that you see here and identify through that. We're going to see here and cover pretty much the orchestrator, zero-touch provisioning, the overlay, and the underlay within here. In future webinars, we'll be covering a little more of the rest, just being that if we sat here and covered all of it, we'd be diving into this webinar for quite some time. The lab architecture we'll be using is identified right here. Obviously, it's a little harder to see, and we'll be diving further into this slide in about 2 minutes and explaining what traffic we're actually looking to have. What we're seeing here going to be failing because we're going to take down the MPLS link live within this lab and show you the failover of the architecture, show that it's going to be hitless from that standpoint. And then we see here and look at the actual live monitor to show that this link went down, failed over to this traffic, and you can see that the video will be streaming, will be live. But the general overview of this is we have 4 different sites connected via MPLS and internet connections, one being an HA and the other 3 sites, and we'll be streaming a connection out of the London site and streaming from the San Francisco site. But yeah, I think that's enough slides. I don't like to kill people with that. I'm going to turn over to Pratik and let's dive into the demo. This is what we're all here.
So as Eric touched upon the lab architecture, I'm going to present it here so that it's better resolution. So the machine that I'm on currently sits in the San Francisco location. This is the machine I'm talking about. And as Eric mentioned, the San Francisco location is an HA setup of the 2 vEdges, other EdgeConnects. The gateway is the VRRP IP, which is .5. And the video I'm going to stream is being streamed out of the London location, which is 192.168.25.4. So just so you know, the Vandis Connect was deployed in these architecture. It has the given transports. The San Francisco location has MPLS, LTE, and Internet. And also the London location has Internet, MPLS, and LTE transports. To prove that we have connectivity from San Francisco to London, I'm going to open this file share, which I'm currently able to access. So basically to prove, yes, this is a mesh and we are able to communicate from San Francisco to London. And now I'm going to play this video, which is being streamed, as I said, out of the London office, and I'm able to access it at the San Francisco location. As this video plays, I'm going to go back into the orchestrator, and I'm going to give you the traffic flows. Just before that, as Eric touched upon, the business intent overlays. So this is what the secret sauce of the solution is. To each deployment you do, you can pretty much match the traffic flows to these business intent overlays. The first one here is real time, which is where our video stream will be matched. I'm going to dive into this quickly. All the business intent overlays are matched on this overlay ACL. Over here, you can define what application you want to match on this overlay. So the real-time video is being matched on the real-time business intent overlay. The flow of this business intent overlay, the way it's supposed to work is first, we are going to hit the MPLS transport. And if for whatever reason that becomes unavailable, we have two INETs at the San Francisco location, which are bonded together. So this will be the second in line. And if all of these go away, we have the LTE to fail over to. So since the video is playing, I'm just gonna. So these are the underlays that I was talking about. As you can see, the video is being streamed and most of the traffic is flowing over the MPLS underlay. If you click on here, you get the live view. Give it a second.
And now that Pratik's actually viewing that video on the screen, I'm going to go ahead and obviously we're in a lab environment, so it will take a few. It's not like I can just walk over and pull a connection. So I'm going to go ahead and down that MPLS connection while he's streaming that video. And we can see everything fail over, and it'll be indicative of that on that flow monitor that Pratik just had up at the real time. And we'll see here and show from green down to red as that connection actually being down. So I'm going to go ahead and click that now as that video is playing. And then shortly thereafter, we're going to have that connection go down. And please keep in mind it's a lab environment, so it should take about 2 to 3 minutes. And then we're going to see that fail over to one of the backup circuits that has been defined in that BizIntent overlay. The BizIntent overlay itself, we could go ahead and it will take. We could literally spend an hour on that. So we're going to break that out and talk about that at a later time. And also, we don't want to inundate people with a lot of information on a new product. So we're going to go ahead and we can see right now that the MPLS circuit is already down, but we'll see here at a later webinar, we're going to see here and dive into what the BizIntent overlay is, the flexibility it really has, and how it really makes this product fly.
All right, so now we can see that the MPLS link is actually down, but the video should continue playing. And this is what we're trying to kind of emphasize here, that to the user, it will be none the wiser, right? They will not even realize that, a link went down or there has been, service degradation.
And as Pratik alluded to, you can see here in the connection can come back up as well in the same fashion, fail back over to that traffic and see here and have it come back up. So I'm going in the process right now of bringing that connection back up within the lab, and everything will fail back to where it's originally supposed to be, as if it never knew the difference. The end user, obviously, if bandwidths are equal, wouldn't know the difference either. It sits here and keeps those paths nice and clean with the path conditioning and ensures the reliability of your traffic as defined within your BizIntent overlay. This also does allow you to use your lower cost links for either failover purposes and make sure that you get the best reliability of those connections. You can also see here and use this breakouts as well to see here and define what guest traffic should be, and based off that policy, send them out that lower cost link so that high cost link you do have or may have is properly utilized for your proper applications, such as your corporate traffic for high visibility traffic, rather than that being clogged up by a guest who wants to sit here and watch Netflix while they're sitting in the waiting room. And as you can see from what Pratik just had up prior, the link came back up, but this is the BizIntent overlay and how it's defined of where it should be, with that primary being the MPLS I had taken down, failing over to the INET 1, then the INET 2, and then if everything has completely gone down, you can even fail over to an LTE connection as see here defined right in front of you. And then lastly, on that bottom, you see here and you have different policies of how it sits here, the redundancy, the path conditioning that it uses, which we'll dive into later webinars. But at least you can see right here what a live view. If you're trying to troubleshoot what's something going on in your environment, this would be indicative of that. You see here and have your overlay. You have the 4 different connections we sat here and mentioned in that overlay itself, and you can see here to see the reliability. that top green line of reliability, everything's functioning normally as it should. And then you can see the MPLS connection came back. So you can see here and look at it real time, go into historical, you can go into the flows and really gather all that pertinent nitty gritty information that you'd want to see within your environment. But also you can see here and have at the same time a nice pretty picture of what's going on within there to ensure that this connection is up, it's reliable, and you can define what those policies are for everything to fail over.
And one more thing, just want to kind of highlight here. It's super simple to provision the devices, as Eric mentioned, the zero trust provisioning. So you don't have to have a large IT staff on site for each of these locations. If you're a global organization, it's fairly simple to kind of deploy these devices. You basically point them to the orchestrator. Once they show up, you just pretty much plug in the LAN interface IP schemes. These are your WAN interface IPs. If you are behind a NATed device, you can choose other options. If it's just an MPLS direct connection, obviously there's no NAT here. You kind of provide the IPs that you have, and this is what you know, the EdgeConnect boost. We're doing 10,000 in this for this site. So you don't have to basically boost all your traffic. You can kind of specify what you want to boost, like real-time video, audio, VoIP traffic, and then pretty much you can boost that, and you don't have to get charged for the entire bandwidth for the site.
Boost would be an additional license. That's really the only additional license here. So you would want to see here and have a good view of the architecture, what's going on, and what traffic is really that important to boost. Obviously, you still have the reliability of the connection, the path conditioning, as shown in the link bonding policy. But at the same time, for any additional traffic that might be a very high priority, you can see here and boost a small subset of that. So it's not required. And obviously, you can see as defined in that business intent overlay, you can see here and define the boost right within there. And then obviously, once the zero touch is done, you can see here and apply any templates you do have. So any basic settings you'd want on these devices, you can define in a template, regional templates if you want as well. And just have them applied to these devices just to ensure you have a commonality across your entire environment, or at least regionally, as Pratik's sitting here showing on the screen right now. With regards to your shaping, your routes, DNS, SMTP, any of that general stuff you want on there, you can see here and define in a template just to ensure there's no typos there. So you make the template once, validate it, and then you can see here and assign devices to the template when coming online from that zero touch. And then additionally, the one thing to mention, there are a number of integrations, and we plan on focusing that down the road as well. With regards to, you can bring this into vWAN. There's Office 365 integrations. As you see, there AWS, some checkpoint stuff going on. Zscaler. There's a few others in the works as well that haven't been released to GA yet, but there's a number of integrations that Aruba is trying to bring to this. So you can see here, integrate into your additional existing solutions, or even bring on additional solutions as needed for any of the big players in there, especially in the cloud space. Yeah, I guess with that being said, Pratik, is there anything else you want to add here?
No, I think for now, that was pretty comprehensive. And yeah, I think if there are any questions in the comment section, we can tackle them now.